Good evening, learners. Welcome to Black Slides online learning platform. This is a platform where you learn the science subjects based on the Msce syllabus at no cost. The only cost you can emit is that of getting yourself some internet data, and then you access the lessons on YouTube. But you don't pay fees. This is free online education based on Msce syllabus, the Msce syllabus. So once again, on this platform, you have the privilege to learn physics, chemistry, biology, and mathematics, 4 subjects. But in the future, we are considering to expand to humanities subjects, Lord willing, as well as languages, so that we have a full curriculum which can be accessed on this YouTube channel entirely for free. So all you have to do is, once you get the link, which I share most of the times on the Black Slides online on WhatsApp platform. There's also a WhatsApp platform, we call it Black Slides Online Learning, where students are free to interact, share ideas, share notes, and share past exam papers, and all the necessary educational materials. So you get the link from there, and then that link will lead you to this channel, the YouTube channel, where you access multiple lessons in video format. So we meet now for a lesson in Form 3 Mathematics in a topic called Trigonometry 1. Trigonometry 1. Once again, my name is Mr. Paul Chilola once again. You can, if you want to talk to me personally, you can contact me on the number that has been shown on this screen. So I always encourage my students, whenever it's mathematics lesson, you must have a calculator by your side, so that should there be need to carry out a calculation using a calculator, also assuming that it's a complex calculation, you should be able to use your calculator and find what we are looking for in terms of calculations. As for me, I already have mine by the side, which I can access whenever I need it. So please get your materials ready. You can pause the video if you are not ready with materials. If you don't have materials closer by, pause the video, get your notebook, pencil, calculator by you. All right? But for the simple calculations, we can do them without the help of our calculator. So this lesson is by public demand by some learners, I think from Maranatha. They requested that we look at Trigonometry 1 again. But the rest of you who might not have problems with the topic, you can take advantage of this lesson to revise, to do gap filling where you missed something. This is the time to do gap filling and to master the key concepts of the topic, Trigonometry 1. Trigonometry 1 is taught in Form 3 in our Msce syllabus. Trigonometry 2 comes in Form 4, I think, in a topic called the cosine and sine rules. We already started looking at cosine and sine rules in our first lesson. We have lesson number 1 on the sine and cosine rule. That's under Trig 2. So once again, you are most welcome to the topic. Please invite your friends as many as possible from different schools. We are not only targeting the students from the school I teach, but students from all over the country can access these lessons for free. All right, during this holiday, this is the best place to make the best use of your holiday time. The best way to spend the holiday days is to be on this platform. Remember once again to like, subscribe, and hit the notification bell. Please, when you are accessing these lessons, you are getting the link from the from the WhatsApp channel, the WhatsApp platform. Click the link. It is the link that will take you to this one, for you to this platform, for you to access the rest of the videos. So once again, you are most welcome. My name is Mr. Pochilola. All right, so this is quite a huge topic, as you can see. You appreciate that there are a number of areas that need to be looked at. So in the topic, we are going to look at a number of things. We are going to look at concepts such as the tangent ratio. So talk about the tangent ratio. So by the end of the topic, you should be able to carry out the problems involving tangent ratio. We are going to define tangent in the lesson. All right. You should be able to use the tangent ratio to calculate. You should be given an angle, given a particular angle in degrees. You should be able to find the tangent of that angle. The tangent of that angle. All right. We'll also look at the tangent ratio in practice. In everyday situation, how do you use the tangent ratio? So this is the application, all right, of the tangent ratio. You should be able to appreciate that tangent ratio considers the adjacent side of the angle in a right angled triangle, and they should be able to use the tangent ratio to find an unknown angle. So talk about the tangent in detail and how you can use it to solve problems. Later on, we are going to look at another trigonometric ratio, which is called sine of an angle, and appreciate its application in everyday life. That's the tangent ratio in action. This should be ratio, not ration. Okay. Later, we are going to look at how we can use the tangent ratio to find the length of a hypotenuse. And we move on to cosine of an angle and also its applications in everyday life solving problems. And then we are going to look at, lastly, miscellaneous problems, mixed problems, only which make use of the topic. So these are the areas that we are going to look at. The areas we are going to look at. Very important to note. So you must get ready, prepared, sit down, have yourself water by your side, be it in a tumbler or bottle, so that you drink at intervals as you learn. You have to remain hydrated throughout the learning process. All right, so we are going to look at the basics of the topic. First of all, why do you have to learn this topic? The intention, what's the intention for you to learn? So why we have to learn this topic is for you to be able to to identify the hypotenuse side. To identify the hypotenuse side. So we are saying the intention of the topic is for you to be able to identify the hypotenuse of a triangle, the opposite side, and the adjacent sides in a right-angled triangle. When given a right-angled triangle, you should be able to identify the sides of the right-angled triangle, namely the hypotenuse side, the opposite side, and the adjacent side. Right, in a given right-angled triangle. And by the end of the lesson today, in part, you should be able to understand and use correctly the terms hypotenuse, the opposite side, and the adjacent side in a right-angled triangle. Very important. So this is the first criterion that you need to achieve, which you should be able to do. So whenever you see a right-angled triangle, you should be able to identify the hypotenuse, the opposite side, and the adjacent side in that given right-angled triangle. So this is what we are going to look at. All right. You should also be able to work out the tan ratio. Given enough information, you should be able to work out the tangent ratio. Remember, tan is short for tangent. So we're looking at how you can work out the tan ratio when enough information has been given. All right. So what does trigonometry mean? I always say that the gateway to unlocking the understanding of any topic is to try to define the topic. All right? So if you understand the topic, it becomes very, very easy, very straightforward to understand it, and to understand the terms, the concepts, and all that, the skills involved. So first of all, let's define the word trigonometry. Trigonometry is a combination of two words in the first place. So trig, try, T-R-I, is coming from triangle, right? It's coming from triangle, so it's triangles that are involved. All right, you may not have trigonometry with respect to shapes other than triangles. All right, so try means it's coming from triangle. While gonometry means measurement. So the term trigonometry means triangle and the measurement. So this is the measurement that concerns triangles. Okay, so by this we are looking at the sides, the angles in it, and all that. And for the time being, we are going to limit our topic to use of right-angled triangle. Remember, a right-angled triangle is one in which one angle is a 90-degree angle. For example, a triangle like this. So this one, you must have an angle there, 90, which is 90 degrees. So this is called a right-angled triangle. Why right-angled triangle? It's because it contains a 90-degree at some point here. All right, so it contains a 90-degree angle. So there's a 90-degree angle here. So such a triangle is called the right-angled triangle, or simply right triangle. Right triangle. All right, right triangle. Okay. So we'll be using right-angled triangles like I mentioned earlier on. In this topic, strictly we'll be using right-angled triangles. Right-angled triangles. So a right-angled triangle is one that looks like this. It has a 90-degree angle. So we have a 90-degree angle here. All right, and the other angles maybe they are acute angles. So I remember acute angles, definition of acute angles, angles that are less than 90 degrees. Okay, and also remember that the sum of angles in any given triangle is 180 degrees. So the 90-degree angle which we have here plus the one up there, and this one here should give you 180 degrees. 180 degrees. So this is what is called a right-angled triangle. Let's appreciate the parts of this triangle. What are the different parts that the triangle has? So if we mark this angle here with the letter X, in some cases we use the letter theta. Theta is a Greek letter which is used to denote angles. You may see something like that. All right, so for the time being, let us use the letter X. So if you look at this angle here, we call this the given angle. The given angle. So if we know this angle here, for the time being, let's just call it X. It can take any values from 1 degree to 89.9 degrees. Remember, this is an acute angle. So acute angles in most cases are less than 90 degrees. All right, so this is going to be our angle of reference. This is the reference angle. All right, so all other sides, the rest of the sides will be with respect to this particular angle, but also with the 90-degree angle which we have. Right, I hope we are together there. So this is a 90-degree angle which we are going to be referring to from time to time. All right. So if you look at the triangle with respect to the 90-degree angle here, the side which is opposite, this side which is facing the 90-degree or subtending the 90-degree angle directly, this one directly, is called the hypotenuse. It's called the hypotenuse. And if you look at this side, you appreciate that it's the longest side of a triangle, a right-angled triangle. It's called the hypotenuse. It's directly opposite the 90-degree angle. It's called the hypotenuse. Take note of the spelling for hypotenuse. All right. Whereas, if you look at the side which is directly opposite the given angle here is marked X. So the side which is directly opposite the given angle, as the name suggests, from the fact that it's opposite, is known as the opposite side. So this side here is the opposite side of this angle. This is the given angle, other than the 90-degree angle. The side directly opposite to the 90-degree angle is called hypotenuse side. The side which is opposite, directly opposite to the given angle, which is this one here, this angle is directly opposite to this side. So that side is called the opposite side. The opposite side. I hope we are together there. We are just labeling the triangle before we proceed. So you should know when you see a triangle, a right angled triangle, you should tell. Which is the hypotenuse side, which is the opposite side, and the side which is forming the given angle. In this case, the side on which the given angle is leaning. This side here. If you remove this side, there can never be this angle. All right. So since it is the side which together with the hypotenuse is forming this angle here, this side is called the adjacent side. The adjacent side is called the adjacent side. It's called the adjacent side. So we have three types of sides in a right angled triangle with respect to a given angle. So the given angle here, x, and then we have a 90-degree angle there. The side which is directly opposite to the 90-degree angle is called hypotenuse side. The side which is directly opposite to the side given opposite to the given angle here, the angle which is less than 90 degrees is opposite. It's opposite, it's opposite. While the side which is on which the angle is leaning is called adjacent side. So you have hypotenuse side, the hypotenuse side, the adjacent side, and the opposite side. I hope you are good on that. All right, that's very good. Now let's do some a little bit of magic here, some kind of experiment. All right, some kind of experiment. If you draw a triangle, don't mind this man here. That's an abracadabra man. Don't be afraid or scared of him. He's just there to show you some kind of magic. All right. If you have a triangle, remember we're looking at a 90-degree angle. If you precisely draw this triangle such that this angle here is 30 degrees. This is the given angle. This is the right angle, and that's the third angle there. If you have this type of triangle drawn precisely and accurately, such that this is 90, this is 30 degrees, all right? If you draw precisely, you can measure the sides. Remember, that's our hypotenuse, which is opposite the 90-degree angle there. This is the adjacent side, and the opposite side with respect to this given angle here. So this is the hypotenuse directly opposite to the 90-degree angle, and this side here is the opposite side directly opposite to the 30 degrees. All right. So if you have these sides, the hypotenuse, the opposite side, and the adjacent side, and use your ruler to measure the length of the opposite side, and also use your ruler to measure the adjacent side, you will find out that if you divide the opposite side by the adjacent side, when this angle is 30 degrees, what you are going to get or to find is a number which is called, can you figure out? Okay, if you take the opposite side, this side, divided by the adjacent side, like shown in this fraction here, when this angle is 30 degrees exactly, you are going to find 0.6. What about that? All right. Once again, we are saying that if you have, suppose you have a triangle which is drawn accurately. By drawn accurately, I mean that this angle has been measured exactly using a protractor. And this angle is also measured exactly as 90 degrees. All right. And you measure, if you happen to measure the length of the adjacent, the opposite side. Remember, this is opposite side with respect to the angle here. It's facing directly there. And you measure also the adjacent side, the side on which the angle, the 30-degree angle, the given angle is leaning. And you divide the opposite side by the adjacent side. When this angle here, this angle, mind you, should be 30 degrees. What you are going to find is a number which is 0.6. That's what we are saying. All right, so the division of the opposite side by the adjacent side has a name. It has a name that we are going to look at shortly. Try another one. If you have another triangle such that it is 45 degrees, the given angle is 45 degrees. All right, and we have our hypotenuse side like that, as well as the opposite side like that, and the adjacent side. And also measure these two. Measure the sides, the opposite side and the adjacent side, and divide the opposite side, this side here, this length, by this length. You must be able to find a very interesting number which represents the tangent of 45 degrees, and that number is always equal to 1. So we are saying the tangent of 45 degrees is 1. If you punch this on your calculator, let's say you are punching that tangent, press the tangent button on your calculator, this one here, and then you press 45. The result is a 1. You see there, the answer is 1. Of course, this triangle might not be drawn accurately to scale, because for it to be 1, it means that the opposite side should be equal to the adjacent side in length. All right. So there's an oversimplification here when drawing this. So we are saying this is 45, this is 45. Remember that the angle should add up to 180 degrees. Maybe if this was made a bit longer, match with this one. Yes, because it's required that the length, the opposite side and adjacent side should be equal. That's for you to get this one here. All right. So that's what we are saying. If you try to put 60 degrees here, you can also try that and work it out. Okay. So for an angle of 30 degrees, the opposite divided by adjacent side was found to be 0.6. All right, meaning that the tangent of 30 degrees is 0.6. You can check here in your calculator. You're getting 0.577350 and so on. When you round this off, it will give you 0.6. It will give you 0.6. to give you 0.6. All right, I hope you're good on that. So the ratio of the opposite side, to the adjacent side. In other words, the opposite side divided by the adjacent side in mathematics is called tangent of an angle. So the angle here should be the given angle. Like in the first case, it was 30 degrees, for which the tangent was 0.6. And for the second case of 45 degrees, the value was 1. And that has been confirmed on your scientific calculator. All right, so the opposite side divided by the adjacent side is what is called the tangent. In short, we just say tan. So instead of saying tangent, you just say tan. And the tan is the shorthand form of tangent. It's the ratio of the opposite side to adjacent side, or simply opposite side divided by adjacent side. It will give you tangent. Which is called a trig ratio. It's a trigonometric ratio. Right. So in mathematics, you write tangent, tan 30. You write tan 30 degrees. The tangent, when the given angle is 30 degrees, it's written as tan 30 degrees is equal to 0.6. So supposing that you want to work backwards, to find this 30 degrees when given this one. Let's say you are given tan x degrees is equal to 0.6. You can do that on your calculator. All right, all you have to do is press the button on your calculator, which is called shift. On some calculators, it's written second function. So when you press that shift and then tangent, it will give you something like tan to the power minus 1. When you punch this 0.6 in your calculator, you should be able to find the angle there. Roughly, this angle is 30 degrees. But if you place 0.55, maybe 7. Okay, let's say 0.9. Okay, 0.58. 0.58. You find that what you are getting is 30.11, which is close to this angle here, which we got. All right, so in most practical cases, you can round off figures. So once again, if you do tangent of 30 degrees on your calculator, you find 0.57735. So when you round this to one significant figure or to one place of decimal, it will give you 0.6, which we have right here. Okay, I hope so far so good, and this must be very, very exciting. So in the past, before calculators came, the ancient Greeks, the Greek mathematicians, discovered that, and they discovered this trend and repeated this for all possible angles. So they got all possible angles as shown here. For example, they chose 25 degrees, 26, 27. They found that there's a trend. The trend is that the values are increasing increasing order like that. Okay, so we are saying in the past, before calculators were obtained, the Greeks had a way of finding tangent. All they were doing is to measure the angles, measure the sides, the opposite side, the adjacent side, and then calculate. They could find this particular trend. Okay, so if you go to 30 degrees, it is found to be 0.57, which when you round off, it will give you 0.6, which we found earlier on. All right. So the figures are accurate to 3 decimal places. All right. So nowadays, we can use calculators instead of tables to find the tangent of an angle. And that's basically what we are going to be doing, because we are not living in ancient days anymore. We are now in the modern days, the technological days, the digital age. That's why I emphasize you must have a calculator with you. It will make life easier for you to calculate tangent of angles. So on your calculator, you press, let's do this together. On your calculator, for you to find tangent of an angle, let's do this together. You should be following. I assume you have a calculator with you. So on your calculator, let's do this together. Press tan. So press tangent. Okay, let's do this together. Press tangent there. Okay, have you pressed tangent? All right, let's continue. Then followed by an angle. I'm assuming that you have a scientific calculator, not the one they use in the shop, in the canteen. Yeah, but this scientific calculator, Casio, and other brands of calculators. All right. Okay. You may not have a very expensive one. Just get a scientific calculator to be able to perform what we are doing here. So on your calculator, first of all, press tangent, like what we just did. So press tangent, okay? Press tangent, then followed by 30 degrees. You may wish to close the brackets there, no problem. Okay? What you are going to find when you press the equals sign, or sometimes you don't need to press the equals sign, it is the value already have displayed there even before you press the equal sign or before you press the answer key. All right, so this will give you a value which is just like the one obtained by using tables. So notice that your calculator is incredibly accurate. It has to be very accurate. That's why it's good to buy these good calculators like Casios. I have on my mind. Original Casios are very accurate. So accurate to 9 decimal places. Like if you look at the display there, you have about this is about what, 11 decimal places. That means my calculator is very accurate. Try after the decimal count how many decimal places there are. All right, that's how you would find the tangent of an angle. First press tangent, tan on your calculator, followed by the angle, the given angle, and then you get the value which you want, which is 0.6. So if you round off this to a decimal place, to 1 decimal place, you will find that it's giving you 0.6. So take note that this should be rounded to 0.6. So if you look at 0.577 to 1 decimal place is 0.6. Great. I hope we are together there. So why all this? Why should you be talking about this? What's the point of all this stuff? Right? Why do you have to talk about this? So don't worry, you're going to find out. Shortly we are going to find out why we need to bother you to teach you this stuff. Why? Okay? So let's look at this tower here. If you look at this tower here, you are saying, how high can this be? How high can this tower be? That's where now you need tangent. Okay, the tangent ratio. Or but if you have maybe a goalpost on a football ground or netball ground, you want to determine how high or how tall a goalpost is or a particular building is. That's where now you need this tool called tangent ratio. All right. So you have the tower as the opposite side. When you have the horizontal line as the adjacent side, measuring maybe say 12 meters, and then the distance from the foot, also given. So here you can notice that this happens to be your 90-degree angle, right? And then this angle here, let's say it is 60 degrees, and the hypotenuse may be given. So okay, so from that what we just saw, this will form a triangle. It will form a triangle whose dimensions or measurements are like this. So you have this your adjacent side with respect to the 60 degree. This is a given angle, and the side which is opposite the 60-degree angle is your opposite side, and that's the height of the tower. All right, so can we now work out using tangent to find how high the tower is? So you have to use the formula adjacent divided by, you have to copy this somewhere in your book. All right, the tangent of x, using the tangent of x, opposite over hypotenuse over adjacent. Remember, this is how we define the tangent. Okay, so in this case it means we are finding the tangent of 60 degrees. The opposite side happens to be our height, the height of the tower. The adjacent side is given as 12 meters. So now the task we have ahead is to calculate the opposite side, which is the height. The height, take note, this is the same as the height, h over 12. So we are calculating the height. What is the height? H. All right, this calls for your knowledge of change of subject of formula. So we are solving for the opposite side, which happens to be the height. So to do that, all you have to do is to multiply both sides of this equation by 12. So multiply this side by 12, also this side by 12. All right, so that 12 and the 12 will disappear. These will cancel each other, so this will cancel that, and now you have 12 times tangent of 12 times tangent of 60 shall give you the height, which is the opposite side. All right, so what is the height of the opposite side? So you go on your calculator once again, you punch 12 multiplied by tangent, in that order, multiplied by tangent of 60 degrees. You find that the height now is 20.7. If you look at this part here, this is actually giving you 20.7. 20.7 or 20.8 if you round that to one decimal place, or if you round, you correct it to 4 significant figures, it will be 20.78 meters. Meters. Very important point to note that. So in this case, it means the opposite side now is going to be 12 multiplied by tangent of 60. So once again, if you punch this on your calculator, you find the height is going to be 20.8. The calculator value is 20.78. So you round it off to 3 significant figures or to one place of decimal. You are going to find 20.8. So you see, this is why tangent is very, very important ratio. It has helped us to find the height of a tower. So you can use the same to find the height of a building, as long as you know the angle of reference, the given angle, which is the angle formed on the horizontal there on the ground between the hypotenuse and the adjacent side. All right, so we have that. Unless you are not sure, please don't hesitate to check with me or to just leave a comment under the comments section below this video. Then I should be able to respond to your concern. Right, so that's what we have. So the towers is 20.8 meters high. So you see the point there, why we needed that. So don't worry, you go through a lot of other examples. You will be trying plenty of examples in order for you to master these concepts, the tangent ratio. All right, suppose we have a triangle such as this. We are given an angle here, x. We have our opposite side here with respect to the given angle, and we're given the adjacent side here, okay, right from our definition. So let us now use that fact to find h. We would like to find h. Can you go ahead to find h? I'll give you 1 minute to find h. What will be the value of h? 1 minute. So at the count of 60 seconds, that will be 1 minute. All right. Still waiting on you. 30 seconds. 15 seconds. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so what have you found h to be? What would be the value of h? All right, so if you follow the same steps, that's your hypotenuse. Remember, the hypotenuse is always opposite the 90-degree angle. This is the largest side of the triangle. All right, and the given angle is 65 degrees. The side opposite to it is the opposite side. So going by the definition, tangent. What is tangent? All right, let me get you to a very popular expression or concept known as the SOHCAHTOA. So katowa. So katowa. Right? Maybe you have heard this before. Okay? It's an acronym which people just made up in mathematics to help simplify problems involving triangles, trigonometry. What this is simple. This means sine is opposite side divided by hypotenuse side. Cosine is the adjacent side over hypotenuse side. Then you have tangent is opposite side over adjacent side. So here we are dealing with tangent. So we are saying tangent is the opposite side divided by the adjacent side of the given angle. We are looking at the given angle, which is 60 there. All right. So we want to find the opposite side. What is the opposite side? That happens to be H, this one here. Right? So we don't know the opposite side, but the adjacent side is known. The adjacent side is also known. The adjacent side is known. The angle is known, but the opposite side is not known. So using tangent of x is equal to opposite divided by adjacent, the opposite side, this one, divided by the adjacent side, which is this one over here, you find that upon substituting 65 for x, tan 65 will be h divided by 8. So as before, you solve for h. That's the one you want to find. You want to find the value of h, the height of the triangle. All right. So again, you what you do is multiply both sides by 8. Remember, this is an equation. What you do to one side of the equation should affect the other side as well. So multiply this side by 8, also this side by 8. All right, so that this 8 here, is going to cancel. This 8 is going to cancel this one, so that in the end what you have is this side, which is 8 multiplied by tangent of 65. So h therefore is equal to 8 multiplied by tangent of 65. You can bring the h to the left hand side, and the 8 times tan of 65 to the right hand side. So you go on your calculator once again. All right, so on your calculator, punch 8, then multiplied by tangent. Remember, it is tangent that we are still looking at. Tangent multiplied by tangent of 65 degrees. You can close brackets if you want. You find that the value of h is going to be 17, sorry, I beg your pardon, 17.2 meters, corrected to one place of decimal. All right, so on your calculator, you have a display of many digits after the decimal point, but it is important to note that this is good up to 3 decimal places. So if you round this off to 1 decimal place, you find it's 17.2. This should be 17.2. 17.2. 17.2. This must be 17.2. All right. I hope you are also okay with this particular example. Please convince yourself. It depends on the information that has been given. Convince yourself that you can handle problems of this nature. Problems of this nature. All right, using tangent. All right, having gone through this, I would like us to pause to end this lesson. Let's call this lesson number 1. And we have been looking at finding the sides of a triangle when the angle is known. Now, second part of the topic, we want to now look at how to use tangent of an angle to solve problems. So you should be able to write down tan ratio. You should be able to use tan of an angle to solve problems, and then we go like that. So this is going to be our next lesson. Let me ask you to go to a relevant page in your mathematics book. If you have some book, go to a relevant page on tangent of angles and try to solve as many problems as possible. Okay, but you can also request some. I'll post them on the WhatsApp chat group where you can access the questions strictly on tangent, okay, so that you apply what you have learned to solve problems. For me, it has been a pleasure presenting this lesson to you in a way that I have done, but in case you have missed something, don't hesitate. You have my number, you can contact me, but also you can comment on the comment section there for extra help. My name once again is Mr. Chilola, Paul Chilola, hoping to meet you in the next lesson. I hope you have learned something. In our next lesson, we are going to look at how we can find angles given the sides, and also the other trigonometric ratios such as sine and cosine. Thank you very much. God bless you.